Well, what we need to define is a sort of equilibrium that allows us to let for the interaction not only of agents between two different of supply and demand, but also the whole interaction simultaneously, because all of the entrepreneurs and all of the banks are looking simultaneously for the best client or best assortative relationship. So we are going to define a stable outcome as being a set of payoffs, one for the bank, one for the entrepreneur, such that two conditions are satisfied. The first one, that the surplus this pairwise relationship generates, which is basically the difference between the output the entrepreneur is having and the cost of collecting the resources, is so the payments options are at least as much as the surplus of the relationship, basically. And the second, the stability conditions require that the two guys who are in any relationship that can be happening on the space of banks and entrepreneurs is doing better than by staying by themselves outside the market. So this option Q, empty theta, empty omega, is the value of the relationship for those guys who are not in the market, which is zero. So this stability equilibrium, stability condition, has two requirements. One is individual rationality, which is given the assignment, which is basically having one bank and one client for all the mapping of possible combinations we have. And these functions, payment functions, the guy should be better off than by being outside the market, and the coalition rationality, which is the second one. That means that no bank and client can do better with other bank or client respectively. Now, okay, we have a definition, but what about? We have many possible functions, many possible assignments, and indeed we can have bunching assignments, right? We can have that one bank is serving all the market, or all the clients are outside the market, just served by one bank, sorry. So what conditions we require for this solution to be identified from the model? Well, we have a lot of information on that. There are a set of papers starting from Shapley and Shubik in 1974 for discrete times, and then continue more recently by Professor Chiapori, that shows that under very elementary conditions, when we are just matching in one variable, we can prove that this stable condition, by identifying the stable condition, the equilibrium implied by the stable condition, which is an interest rate and allocation, is optimal, efficient, unique, positive assortative under the framework of marginal cost decreasing, and pure. And by pure I mean it's a one-to-one relationship. At this moment, we are not going to test that assumption or that result. We can see how far we will try to see how far we can reach with purity result, and then later maybe introduce some restrictions for having bunching. Okay, but so far with the conditions we have for the model I'm proposing, we have all of these properties for the equilibrium. And well, using all these properties, these research are going to use two fundamental elements for characterizing the interest rate. One is the uniqueness of the stable matching. Under these assumptions, we have what is known as transfers.
What's the definition of positive assortative when there's one-to-many matching like this?
You cannot have that indeed. You can have that but on bunching. So the best captures a bunch of the best.
But they're all the same. But all the people they capture are the same, you're saying?
In this case, yes, but because we are assuming that we have non-atomic, you cannot have a bunch of peoples of the same type. Just there's a continuous with no mass at each point, but just no mass at any point.
So is this one-to-one matching?
Yes,
thought you
exactly.
said you could have multiple clients at the same bank.
No, I'm saying that we are having one-to-one, which is one bank, one client.
Okay.
That's the implication of my model. Yeah.
Doesn't that seem sort of counterfactual? So why wouldn't all the people just want to go to the best bank?
Well, because in my model, it's not necessarily a bank. It's an intermediary. So we can think about a branch of the bank or a specific manager or a specific executive that attends particularly this client. So that's why I didn't use the word bank at the beginning. Just it's like an intermediary. It's like an executive that have at most one client. Executives lives in the branch and the branches lives in the bank, but I'm allowing to so far to permit for a lot of executives around trying to capture the best client. So there are two conditions that allow me to continue pursuing the model. One is the uniqueness of the stable matching. The second one is that from the interaction of clients and intermediaries, later banks, the efficient sharing rule that arises from the interaction of these two guys, and by this I mean, okay, once that we know which bank match which client, the optimal division of the surplus is a Pareto solution.
Wait, quick question. So if you're saying that each executive is sort of is one of the guys,
Mm-hmm.
then imagine there's one bank that's better than all the others.
Mm-hmm.
Then in your model, sort of the different branches of the bank are competing against each other, right?
Exactly. They're competing against each other. Yes, that's true.
So what happens if they don't do that? So like,
So far, no. I'm moving in that direction. Yeah, so far, I'm not. I don't know what this if this branch of this bank is better than this branch of this bank. So I can run branches of banks instead of banks.
how concentrated are banks in Mexico?
We will see that in a moment. And for identification of the equilibrium, we will see that in a moment indeed. It's interesting. I'm going to assume that we can normalize the measure of intermediaries to be rho. So we have the same mass of intermediaries and entrepreneurs, rho is equal to 1. If there are more intermediaries than entrepreneurs, rho is higher than 1, and vice versa. So what this rho is allowing me to do is to have identification of the solution of the prices, which is the interest rate. Okay? So given the pure assortative matching solution, this implies that the best guy matched with the best guy, match the best entrepreneur matched with the best bank, and we have the solution for all the market. And if we have this rho lower than 1, that means that we have more entrepreneurs than banks in terms of the density, then the solution of the model would be given by these 4 equations. The first one is the matching function. It tells me which entrepreneur is matching with the bank omega. The second one is the equilibrium utility for the entrepreneurs in the market. Why? Because the guys who are outside the market have utility 0. We normalize that. This is the profits for the bank given credit at the market, which is just the difference between the surplus and what the entrepreneur is having. And interesting enough, the interest rate, the price for the capital the entrepreneurs is paying to the banks. Yeah.
Are you gonna look to data for rho? Because
Yes. Well, rho is the relative measure of the whole market. Yeah. But what I'm guessing is that what we observed at the beginning, the expansion in the market, is an increase in rho, indeed.
because I mean it seems like in most matching models, rho would be given by technology or biology, just so the relevant number of men and women or something. But
Mhm.
here, if you can people can form banks. So if rho is less than 1, so there's too few banks. There's some surplus to be gotten by going out there and forming a bank. So why aren't people doing that? I guess.
Well, that's a good idea. I'm not modeling that. It's just like an essential.
I guess why doesn't capital flow from the U.S. or something like this?
Exactly. So that's a good idea. That the formation of banks can be endogenous. So far, it's just given. So you have the technology to collect, and you have the technology to produce. You cannot trade that technology to collect, basically.